In September 2016, close to 50,000 mining industry professionals from around the globe gathered in Las Vegas, Nevada for Mine Expo International, the largest mining show in the world. Mine Expo was the perfect venue for SKF to launch the first ever Mining Insights speaker series. SKF developed the series to help mining industry professionals gain insights to overcoming the challenges faced every day within the industry. A diverse range of experts from across the world of mining presented real-world case studies, industry trends, technologies for improving reliability, productivity, safety, and much more. Our next presentation is Achieving Excellence in Asset Management with Remote Monitoring of Mobile Mining Equipment. Our speaker is Manager of Predictive Maintenance at Cloud Peak Energy, which is one of the world's largest safe coal producers in the country. He has over 30 years experience performing and supervising maintenance of plant and mining machinery. So please put your hands together for Mr. Tim Hopkins.
Thank you.
Morning, Tim. The stage is yours.
Good morning. Well, I was called Mr. That's one of the first times I think I've heard that, so thank you. I'll remember it always. My name is Tim Hopkins, and I work for Cloud Peak Energy. Cloud Peak Energy, for those who don't know, is located in Gillette, Wyoming. I joined Cloud Peak Energy in 2009 when it was known as Rio Tinto Energy America. Shortly thereafter, we spun off and became Cloud Peak Energy. My present position is the Predictive Manager in the Asset Management Group, where I provide guidance and supervision to a group of individuals that perform precision, predictive, and training services throughout our maintenance departments. Cloud Peak Energy, as I mentioned, is headquartered in Gillette, Wyoming. We are the only pure-play coal mining company in the Powder River Basin. We presently ship 60 million tons annually, which is down slightly from our 90 plus million tons a few short years ago. We own and operate 3 coal mines in the Powder River Basin. The Antelope Mine and Cordero Rojo Mine are located in the state of Wyoming, and the Spring Creek Mine is located in the state of Montana. For those unfamiliar with the PRB, red arrow shows the location, general location. The green shaded area in Montana and Wyoming is where we do our work. When I was asked to give this presentation, its primary focus is the wireless online condition monitoring. One thing, I was talking with some of the guys earlier, we should be under no confusion or illusion that buying a high-tech system is the answer to our problems. There are many things that have to happen in relation to the purchase and development and implementation of a wireless program or process that will give us the results of reduced maintenance expenditures and also increase our reliability. Our focus initially when I joined the company in early 2009 was to eliminate the contracted predictive maintenance that we were paying for, and also the precision maintenance, i.e. alignments, laser mechanical alignments. Early on in our predictive maintenance audits of the plants, we identified several opportunities. One of them was the installation and repair issues or opportunities that we identified with our early audits. Our focus with the online systems, the wireless systems, eventually matured to a point where we targeted our mining shovels, our drag lines, and our haul trucks. I should back up just a little bit. During our plant and our shovel and drag line predictive maintenance program development, we did install the foundation equipment, the sensors, the cables, the J-boxes to a common location on the majority of equipment, with the hopes that someday we would we would identify and develop and implement a wireless system. So just backtracking a little bit, there was a lot of work with the manual collection of that equipment that did take place. During those condition monitoring audits, we identified a lot of opportunities, and this speaks to the importance of addressing other issues at the same time that we would install, with the hopes of installing a wireless system. As with many maintenance departments, we were challenged with some of the issues of improper installation, inducing potential failures and such. We started up an alignment team with lasers, mechanical and optical tooling, precision tooling, so we could help or assist the sites both in the plant and on the mobile equipment with installation of rotating assemblies. We began an acceptance testing program. We sat down and spent a couple days writing standards for new and rebuilt equipment that met our standards. Essentially any new or rebuilt rotating assembly, i.e. a fan, a reducer, a motor, must be tested before it's allowed, before we are allowed to take delivery. And that's significantly reduced the potential for failure as we've installed the equipment that we know is to our standards. At the same time, we started developing a training program. It took about 1.5 years, and the training program was focused at the industrial mechanic, the millwright at the plants, and also at the dragline, shovel, drill mechanic crowd. And initially, as I mentioned earlier, one of our main goals was to eliminate or reduce contract services, whether it be predictive or precision. Some of the concerns with the predictive maintenance, especially the condition monitoring, was the expense. I think all of us know that a lot of this equipment is very expensive and time consuming to install. All valid concerns, and we took that to heart and spent quite a bit of time researching before we began the purchase of that equipment. There were a lot of unknowns, specifically our ignorance. We didn't have the knowledge or the expertise. Although I had experience with online systems, I had none that was able to transfer data files across the radio, so that was a challenge that we would have to address. Buy-in was difficult. I think most of us know anytime we have a new process or program implementation, it's usually a challenge to get people that feel they're doing things correctly or right to change. So that was definitely a challenge. Interfering with production was a concern of management, and it was valid at the time. We began many of these initiatives. We were producing 90 million plus tons annually, so we had to pay particular attention to interfering with production of shovels and haul trucks and drag lines. Again, we lacked the experience. Although the group is relatively new, at about 7 years old, my personal experience was with online systems was all hardwired, so I didn't have the experience with the wireless. And from what I gathered in my initial research, there weren't many people that did. Installation requirements are intense. These systems are very neat and they're nice to have, but they require a significant amount of labor to install them, not to mention the time that we take these machines out of service. Selecting a system was a challenge also. We didn't like the idea of going with the traditional predictive suppliers like CSI or SKF initially, so we opted to go outside the box, and we identified I believe it was an 8-channel multiplexing data acquisition device that we selected for our initial haul truck project. Once we were able to transfer those data files successfully, we moved that project forward and equipped our Komatsu 830E fleet with the 8-channel devices, which gave us wireless monitoring of the wheel motors. We did do some research with the engines and the front corner groups and alternators, but ultimately selected to just the wheel motors as our main focus on haul trucks. My boss happens to be here, and I thought it was worth mentioning that he's made the comment over the years that I've known him, going on 8 years, that technology is easy, the ologies are difficult. With the ologies are obviously referencing the psychologies. So I think all of us that have been a part of implementing a process or project know that the tools are easy to buy. It's convincing the people that it's a good thing. Fortunately for me, I have the support. As I mentioned earlier, buying the equipment or the tools is easy. That unfortunately does not give you the results that most people desire or wish to have. The asset management team that I'm a part of, we were allowed to build a team over time of what I believe are some of the finest predictive maintenance technicians in the world. Having experience with other reliability groups, particularly in the paper industry, I worked for International Paper at one time. I can tell you that the abilities of the predictive group that I have the pleasure of working with far exceed anything I've ever been exposed to, especially when you consider the challenges of variable speed machinery. It took a period of years, probably 3 years, to build the team of 5 men that we presently employ as reliability technicians or predictive technicians. Those individuals were selected because of their skill sets and obviously the integrity that they had. We provided the training, and they truly are, at this point, experts. Leadership support. I think with most programs, we all know how important leadership support is. Without that, we wouldn't be where we are today. We do have the support from the highest positions in our company to give us the tools we need and the support to continue on. As with any program, purchasing equipment is not enough. The maintenance personnel that we have to communicate with, whether it be on a drag line or in a plant, we all have to be on the same page and speak the same language. So it's very important that we bring their skill sets up. As I mentioned earlier, we developed a maintenance training program for industrial mechanic. That's a huge part of this initiative. The maintenance personnel, whether it be the technician or a supervisor, skill sets have tended to be somewhat less than we desired. So we spent quite a bit of time in developing this program, and we now offer a 5-week program that covers 5 months, 1 week per month, and it serves a lot of purposes. One of them, and it was initially my main goal, was to foster those relationships with the predictive group. That's exceeded my expectations or ours. Promoting predictive maintenance, again, we have to be very careful how we promote these programs, because typically the individual that we're alerting may have been the person who has performed that work, and that becomes part of that ologies topic. I should point out, if you look at these images, you can see in the top right corner there's a whiteboard at work, and that's one of our engineers that's helping one of the students with a calculation. I'm not sure what that was exactly, but the image in the middle with the yellow wires, that's actually a prop that we built, one of many that we're able to power up. We've got the ability to put a 16-channel data acquisition device on this. We have the capability of shiv alignment, training and testing, and also direct couple. So what we do is we can actually show the student the importance of alignments. Again, this is all about precision installation. It serves us nothing at all if we don't have a machine that's assembled or installed in a precision state. Really, the predictive or the analyst his value declines. So we focus heavily on teaching the students how to do some of these precision maintenance tasks to a high degree of competency. This particular prop allows us to put an amp clamp on the power supply, and we'll use a direct couple for a demonstration, and we'll go ahead and move the shafts. Once they've established the collinear access, we'll move the shaft for an angular or parallel misalignment and show them the increase in power consumption. So it gives them a real good understanding of the importance of precision maintenance. Again, the people, the psychology is huge. I mentioned fostering the working relationships. These classes weren't only meant to bring the levels of the mechanics up, they were also meant to bring the skill sets of the predictive analyst to raise them, and also at the same time foster those relationships. The feedback that I've received from both has been exceptional. The students can't believe how much there is in the maintenance world, and I think that alone shows it as a success, and also the greater appreciation for each other's roles. Those health audits now have a different meaning. When we perform these predictive audits of their machinery, they want to talk to the predictive analyst now. Again, careful promotion of these successes is very important, because obviously the individual that's done the work, and he or she may have felt very good about that work, and we identify a liability. It's a very sensitive area and needs to be addressed with kit gloves. The training, as I mentioned, we provide that to all maintenance departments. One thing, I'm a big fan of Ed Deming, and our training program is no fluff. It's practical and to the point. Our 5 weeks of training give them the foundation to understand the theory and application of predictive maintenance, precision maintenance, and just general maintenance. Moving on back onto the wireless portion of this presentation, we did select the SKF hardware and software ultimately. The device that we proved successfully our concept was a multiplexing unit, and we wanted to move to a simultaneous device like the SKF IMX. So, in my previous experience in the pulp and paper industry, I also had used the SKF device at the time for my online condition monitoring, and was very happy with it. The new program, the software we use with SKF Aptitude Observer is user-friendly, and the analysts prefer it over many of the softwares that we tried while developing this program. I think it's worth mentioning that these programs require a significant amount of commitment. The work that's involved in installing the accelerometers, running the cables, the J boxes, is tremendous. Both internal labor and contracted labor requirements, power supplies, just about anything you can imagine with installing new equipment. So this is not a quick fix. It takes a number of years. I would say that our project is probably in its 4th year, and we're fairly close to completion with the wireless. This is a simplistic overview of how we communicate or how we transfer our data files. For obvious reasons, I wouldn't want to go into detail on exactly how we do it, but we are able to wirelessly transfer data. We do transfer data files through our radio from sites. We collect data 140 miles away with no issues. Fortunately for us, we have an excellent IT department and some networking people that provide us with their expertise to solve our dilemma, because we definitely didn't have any idea how to do it. So big thanks to them. The results, I can tell you that our results were better than we had. Our 5-man team presently analyzes data received through wireless data transfers of 20 electric mining shovels. That's essentially our fleet, 5 of 6 drag lines, and 12 of our 80 haul trucks. So we have plans to add remote monitoring equipment on the remaining drag line and also a good portion of our haul trucks. It's worth noting that this team of 5 men, 4 are dedicated to the predictive work. When I started with Rio Tinto Energy America, I believe my boss told me it was about $1.5, $1.7 million annually for predictive and precision maintenance contracted services. We now perform 100% predictive maintenance and precision, and a majority of precision installation alignments for our company with 4 to 5 personnel. The title understates the importance. This graph represents a process that we use in our CMMS. We use Ellipse. This happens to be the work request module. When I joined the group, we were somewhat archaic in our means of conveying liabilities to departments. One of the things we used was a spreadsheet, email, and one of the other was a telephone call. So I suspect you can imagine how many missed opportunities arose. So we began utilization of the work request process in 2012. That data happens to be 6 months of data in 2012. You can see that there's a significant amount of liabilities that have been conveyed to the sites. The main reason that we began using this method was to document and obviously start collecting data and history. I believe there was in excess of 350 in those 6 months, so it gives you an idea that if you look at the downward trend to 2016, obviously 2016 is 6 months. I believe that there's approximately 50 to 60 in that time frame, and most importantly, we have to understand that the majority of this work is no longer reactive work or repair. It may be alignment work that's been scheduled to facilitate the repair of another component. We still have some lubrication issues, and that's also visible in this data. I would say it's about, I want to say it's about a 70% drop, roughly. Additional results, this is a combination of our DDS drill, dragline, and shovel cost, and it includes our plant. Unfortunately, we can't remove certain things that just occur because of degradation over time, like conveyor belts, shovel teeth, various wear items, components. So I've got to give credit to a gentleman that's helped me with collecting this data and compiling it for me. Russ Hallcroft is our business improvement manager, and without him I wouldn't have had this data, but we're sure looking forward to removing some of the other items in here that hopefully show a much greater improvement than what we have. Although in 2009 through the first half of 2016, we've experienced a 30% decline in labor, and it's worth noting that this is a cost for prime tons. So regardless of our production, it's a tremendous reduction. Repair components, 15% reduction, and outside services or contracted maintenance, a 45% reduction. Another graph showcasing the continued decline. Again, this is cost per prime ton. It's worth noting in 2016, we perform typically the majority of our major outages in the first half of every year. So we suspect we'll see a significant reduction in the height of the 2016 column by the end of this year, continuing our steady decline for repair, parts, components, labor, and outside services. Another graph representing similar data, drills, drag lines, shovels, and plant equipment combined. The dotted line is our production, and again, this is cost prime ton. So you can see the continued decline, and as I mentioned, 2016, we suspect will be even better at the end of the year. I know we're all concerned about safety and being first and foremost in our minds. Cloud Peak consistently ranks near the bottom, and we do believe that planned proactive work is a portion of this success. As of August 31st in 2016, our AIFR rate is 0.09, and I believe that is the best in our industry. My boss gave me this, and I think it's worth reading. 2.25 million man-hours worked, one reportable incident involving debris in an eye that required prescription eye drops. One man would have to work about 1,100 years to accumulate that many hours. I'll read this because I believe it's important. Learnings, again, safety. DuPont reported that the most likely person to be injured is a maintenance technician with less than 2 years experience doing reactive work. ExxonMobil reported accidents are 5 times more likely in maintenance when doing breakdown work than when doing planned and scheduled work. In 66% of the companies, 60% of the injuries occur while doing reactive maintenance. Pulp and paper industry concluded you're 28% more likely to have an accident when maintenance is reactive versus planned. And obviously that's the goal of predictive maintenance, is to move from a reactive maintenance to either a predictive, reliability-centered, or proactive program. This is an example of real cost avoidance for Cloud Peak Energy. This particular defect was identified on a 7495 Cat mining shovel at our Spring Creek mine in Montana. The predictive analyst identified a BPFO fault in the outer race. The vibration case for, if you look on the left column, the cost was the actual cost for that repair using the vibration analysis. If this would have been a number of years ago, I suspect the degradation would have continued, and the likely cost, if you notice on the cost on the right column, we do have a delta of $1.2 million just for this one example. This is FFT, this is envelope 3, I believe, G's envelope, clearly showing wireless received data for that particular fault. You can see you can clearly see the fault in this bearing. That is actually how it showed up on the FFT for enveloping 3 or DMOD. This is a time waveform used to confirm the presence of that fault. And this is a waterfall of that data, so you can clearly see the defect presence. In summary, we believe that the predictive maintenance, and especially the mobile equipment wireless capabilities, has played a tremendous role in reducing our cost and also improving our reliability. But we're not naive enough to believe that the most important part of this equation is the people we work with at the sites, the mechanics on the drills, the drag lines, the shovels, and then the plants. So all the things that we put in place help foster those relationships and improve skill sets to where we work together as a team.
Tim, thank you very much for that.
You bet.
Okay.
I'll buy you a new battery.
Just one observation, I think. Thank you. That was a very compelling presentation. As we heard from Cecilia at mining.com yesterday, commodity prices are clearly taking longer than expected to recover. Now, this makes the need for innovation even more imperative. What are you doing to address this in terms of your strategy?
Well, as I mentioned, I do believe that the training and having a better understanding of our predictive capabilities, utilizing the systems that we put in place, will continue to reduce our maintenance expenditures and improve our reliability. So that's our job, and that I have no doubt we will continue to be successful.
Very good. Thanks a lot,
You
Mr.
bet.
Tim Hopkins. Thanks. Join the conversation. If you haven't already, be sure to follow SKF Mining Insights on LinkedIn and look for more case study presentations and other valuable content on skf.com/mining insights.